Hello everyone, welcome to my calculus lecture. Uh, in this lecture, we continue to go over examples on related rates. So the first example in this lecture uh, is the following. Gravel is being pumped from a conveyor belt at a rate of 30 cubic feet per minute, and its coarseness is such that it forms a pyre in the shape of a cone whose base diameter and height are the same. So the question is, how fast is the height of the pyre increasing when the pyre is 10 feet high? So, the following figure shows the cross section of the cone-shaped gravel pyre. So, since H and R, remember, no, the diameter and the height are the same, So in this case, if the radius uh, of the cone is r, then h is going to be 2r, right? So that's what we have here. So again, how fast is the height of the pyre, means that we are trying to find the dh dt when the pyre is 10 feet high, when h becomes 10 feet high. And what's known here is, what is that? The volume, okay? So the amount of gravel being pumped into, being pumped, right? Uh, that's 30 cubic feet, per minute. So in other words, if we denote the volume by V, big V, that's going to be dV dt. That equals 30. All right. So those are the known quantities. So having said that, let's get to my notepad to work on it. So in this question, the amount of gravel, okay, the amount of gravel that equals the volume of the cone. Okay, uh, so the volume of a cone, like ice cream cone, that's with radius r, the radius of a circular base, right? So that's going to be one third pi r cube, pi r squared, yeah, one third pi r squared times h. So that's the formula, right? That's the formula. And in this case, we have, we see like three quantities here, right? The volume is related to two quantities, r, the radius, and also height h. But then h and r are related, right? They have a functional relationship. What is that? H equals 2r. So actually, using this relationship, you can reduce, the v as a function of a single variable, right? Not two. Right. So here, the r equals h divided by 2. So you can write down v h as a function of pi, uh, one third pi times, the, what is that? H over 2 squared times h. So that becomes 1 over 12 pi h cubed. The reason we are writing v, as a function of h, not as a function of r, because what we are trying to find is dh dt. Remember that? So we need to represent the volume in terms of the height h, right? Obviously. Okay, so we now differentiate this with respect to time. So dv dt, right hand side, we will have to use it. So the v is a function of h, but then h is a function of t. We are taking the derivative with respect to the innermost variable t. So we will have to use chain rule also. So that's gonna be 1 over 4 pi h squared, and then multiply that by dh dt. Right? So what we need to find is dh by dt to solve this equation for dh by dt. We get that's gonna be 4 over pi r squared dv dt. Okay, so the 4 divided by, now we are putting in values, right? So plug in 10 for r, so we have 10 squared, and then plug in 30 for dv dt. Okay, so we will get 1.2 over pi. The quantity is going to be feet per minute, right? Feet per minute. Or as a numerical approximation, this will be approximately 0.38 feet per minute. Okay, that's how fast the height is increasing. Okay, how fast. So every minute, right? Every minute, the height is increasing by 0.3 feet. Right? That's what it means. Okay, next question. Next example. A ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 feet per second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? Okay, so that's the question, right? So the question is depicted in the following figure. Okay, so we have this here, the the vertical, I mean the wall, right? That, and then this is the bottom, right? And here blue line, okay, resting against the wall. That's actually depicting the ladder. Okay, so here we have two quantities, right? X and Y represented by X and Y. So X and Y, X is the distance from the wall to the bottom of the ladder, and also Y depicts the distance from the top of the ladder to the floor. Okay. Right. And also, so in this case, X and Y, uh, and also the length, the ladder, right? The length of the ladder, they form a right triangle. I mean, so the ladder or these three quantities form a right triangle. So they satisfy, what is that? The Pythagorean law. In other words, x squared plus y squared is going to be 10 squared 100, right? So having said those things, so we are ready to work on the example. Okay, so let me write down. So x is the distance from the wall to the bottom of the ladder. Okay, and y represents the distance from the top of the ladder to the floor. Okay, so as I mentioned also earlier, we have the following Pythagorean relationship satisfied: x squared plus y squared equals 100. Okay, right, so we are ready to proceed. All right, so we differentiate this equation here, x squared plus y squared equals 100 with respect to t, of course. So dx by dt, no, actually, 2x dx dt plus 2y dy by dt equals 0, right? So divide this equation by 2, cancel this and this. So, we have the equation x times dx dt plus y times dy dt equals 0. Okay, so now we can solve it for dy by dt. That's what we are being asked, right? Going back. So what's the question? How fast is the top of the ladder sliding down the wall, right? That's the question. So what is the dy by dt? That's the question. So we are going to solve this for dy by dt, and that will be negative x over y times dx dt. Okay? So we are trying to find the dy by dt when the bottom of the ladder is 6 feet uh, uh, away from the wall. Okay, so when x is 6, right, when x is 6, uh, we are trying to find the right, and also the dx dt is given by 1 feet per second, right? So we know that too. Okay. So when x equals 6, right, x equals 6, from this Pythagorean relationship, you can easily find the y. Okay, so y is going to be square root of 100 minus 6 squared, right? 36. Okay, so that's going to be 100 minus 36, that's going to be 64. So square root of 64. 64 is what? 8 squared, so that's going to be 8. So y equals 8. So we have negative 6 over 8 multiplied by dx dt. Dx dt, that's 1, right? Yeah, just to make sure that, yeah, 1/5 per second, okay? So times 1, so that's going to be negative 3 over 4, okay? Negative 3 over 4. The unit is feet per second, okay? So dx dt, right, is negative 3 over 4 feet per second. So that's the final answer. Okay, that's not bad. Okay, so here comes next example. A water tank has the shape of an inverted circular cone. Actually, I have never seen one like that. Okay, but why not? With a base radius 2 meters and height 4 meters. If the water is being pumped into the tank at a rate of 2 cubic meters per minute, find the rate at which the water level is rising when the water is 3 meters deep. Okay, so that's the question. In this case, let us take a look at the following figure, which depicts the cross section of the water tank. Okay, so cross section of, since the water tank is in the shape of a an inverted circular cone, the cross section is going to be an inverted triangle, right? An inverted triangle. So the radius of this cone is 2, height is 4. Okay, so here like R depicts just some like radius somewhere uh, down there, and then H is corresponding height. Okay, right. So what's important to note in this problem is that as you can see from this figure, right? From this figure, right? The uh, the triangle in black, right, with the base 2, height 4, and the triangle, right, whose two sides in red, right, given by R and H. Okay, so these two triangles are similar. Okay, so these are similar triangles, right? That's important thing to know. Okay, so the volume of why is that important? Because the volume of water, in this case is going to be same as when the height depth actual depth of water is h, right? The volume is the amount of water is going to be same as the volume of this smaller the cone. Okay, that's given in terms of h and r, but using using the fact that these two right triangles are similar, and we can actually reduce it to the volume as a function of a single variable. That's important. Okay, so that we can actually calculate the problem. So uh, having said all these things, right? So we are going to go to my notepad to do the work. Okay. So uh, using, I just mentioned, okay, so using the similarity of the two right triangles in the figure, we have the following ratio R over H equals 2 over 4, which is 1/2. So we can solve it for R. So R equals actually 1 over 2 H. Okay? And so the volume, in this case, the volume of a right circular cone, right, with radius R and height H is 1/3. We talked about this formula, right, in one of the earlier examples, H, right, pi squared H. But now, to replace R by, H over 2, we get pi over 12 pi times, oh, no, I wrote down already, pi, just the H cubed, right, H cubed. Okay, so now we differentiate this. So dv dt with respect to time t. So we have a pi over 4 h squared, and then multiply that by, we gotta use the chain rule, right? d h dt, okay? So, the v is a function of height. Oh, no, in this case, not height, but depth of water in the water tank, right? Anyway, so, so v is a function of h, but h is also a function of time t. And we are taking the derivative with respect to time variable t. So we are trying to find the dh dt. So we have to solve for dh dt. So that's going to be, 4 over pi h squared. Okay, and then multiplied by dv dt. Okay, so now we are ready to calculate the values, right? Okay, so, let's get back to the question to make sure that we have it. So, when the water is 3 meters deep, so when h equals 3, right, and also we need what? dv dt. dv dt is given by 2 cubic meters per minute, okay? Pi 3 squared, right? dV dt is 2. So altogether, that's going to be 8 over 9 pi. 8 over 9 pi meters per minute. Okay, so that's how fast the depth of water in the water tank is rising. Okay, and numerically, this is approximated to 0.28. Okay, so approximately this is 0.28 meter per minute. Okay, so that's the final answer. Okay, so here's another example. A street light is at the top of a 15 feet tall pole, and a 6 feet tall woman walks away from the pole with a speed of 5 feet per second along a straight path. The question is, how fast is the tip of her shadow moving when she's 45 feet from the base of the pole? Okay, so that's the question. And the following figure, right, is depicting what's described in the question. Okay, so here like it's actually in the form of a right triangle, right? So here that height of this right triangle is 15 feet, light pole, right? Light straight light pole, pole with the length 15 feet, and actually there are two quantities being involved in this case, right? X and Y. Okay, X and Y. So what is X? So X is the distance. X is the distance from the light pole here to the woman. Okay, to the woman. So this is X. Okay, so the lady with the who is 6 feet tall, and Y represents the distance from the light pole to the tip of her, the shadow. So that's going to be right. That's going to be Y. Okay, so what do you see here? So you see actually two right triangles, right? One big one, and inside it there is a smaller one. And these two triangles also satisfy a similarity relation, right? These two triangles, right triangles, are similar. Yeah, that's important thing to know. So we are ready to work on the problem now. Okay, so X is, like I said before, distance from the light pole to the woman, y is the distance from the light to the light pole to the tip of her shadow. Okay, tip of her shadow. Okay, so using, so I mentioned that, you know, the two right triangles in the figure, right? They said they are similar. So using the similarity of the two triangles, the two triangles in the figure we obtain the relation between x and y. I mean, from the question, uh, well, it's clear that x and y are related, but how related? Okay, and similarity tells us, you know, the relationship. So that's, you know, 6/15 equals y minus x over y. So this ratio uh, holds, because those two right triangles are similar. Okay, so from this you can solve for y, and if you solve this equation for y equals 5 over 3, 5/3 times x. So x and y is a linear function of x, or the other way around. You can also say x is a linear function of y, but you know we have what we need. Okay, so we are trying to find what how fast the tip of her shadow is moving, right? So we are trying to find the dy by dt. That's what we are trying to find, the dy by dt. So by differentiating this, we have 5/3 times dx dt. Okay, so that's going to be 5/3. So what do you know? In this case, actually, uh, oh, sorry, this does look like 8. 5/3, right? 5/3. Yeah, 5/3 times dx dt, right? So dx dt is 5, right? That's 5. So that's going to be 25 over 3, feet per second. So what you see here, the speed of the tip of her shadow does not depend on how far she is from the pole. Okay, it does not depend on x. Only depends on, you know, how fast she is walking away from the pole. Okay, only that. But it does not actually depend on, how far she is away from the pole. So that's interesting. Okay, right. Okay, I believe this is our last example on related rates. So here comes the description. A plane flying with a constant speed of 29 kilometers per minute passes over a ground radar station at an altitude of 13 kilometers and climbs at an angle of 20 degrees. So the question is, at what rate is the distance from the plane to the radar station increasing 3 minutes later? Okay, that's the question. So let us take a look at the following figure, which depicts, what's described in the question. Okay, so here we have a radar station. So the airplane, the altitude of the airplane is 13 kilometers, right? Okay, so and then what is that? At an altitude of 13 kilometers, right? It, the airplane is passes over and then climbs at an angle of 20, climbs at an angle of 20, uh, and then flies away, right? Flies away. So, the whole thing here, what is that? So there are also two quantities, right? So uh, C, okay, so C is, how far, airplane that flies away from the gas station. I mean, not the gas station. I'm sorry, radar station, and the A, right? A is the distance between radar station and the plane. Okay, so all these quantities form a triangle, but in this case, obviously, it's not a right triangle, right? So the question is actually a little more complicated than that. Okay. So here C and A, and also here uh, 20 is the elevation of the the airplane, right? Uh, from the sorry, so the actual 20 degrees tells you like what the angle of uh, the what is that uh, the airplane, the increases, its altitude by 20 degrees, right? Once passing the radar station, right? And but in this triangle, this entire angle opposite to right angle opposite to the side A is also denoted by theta. Okay, but theta is actually easily calculated in terms of this, the 20 degrees, right? Because uh, here we see right angle, so theta is given by 90 degrees plus 20 degrees. That's going to be actually 110 degrees. So theta is actually 110 degrees. Right? So having said all this, now we are ready to work on this question. So let's get to my notepad. So before we go further, right, so what we have it is a triangle like that. Okay, so let's call this side A, this side B, this side A, and this side C, and the angle uh, opposite to side A, let's call it theta. In this case, A, B, C, and theta, they satisfy a nice law, which is called, if you recall, you would have learned this from trigonometry, a trigonometry class, the law of cosine. Okay, the law of cosine tells us the relationship between these quantities, A, B, C, and theta. Okay, they satisfy the following nice equation. A squared is given by B squared plus C squared minus 2BC cosine theta. Okay, cosine theta. So we have this relationship. And then as I mentioned also in our problem, theta equals 90 degrees plus 20 degrees, which is 110. Okay, 110 degrees. Uh, I am going to use a radian angle, so corresponding radial angle, you know, is 100. You can easily convert it, right? Knowing that 1 degree equals pi over 180 radian, right? Radians. So that's going to be 11 over 18, 11 over 18 radian. Okay, radians. We are not actually going to, use what is that, the angle value itself directly into the calculation, but we need the cosine of it, right? Obviously, from this, the law of cosine, that's what we are going to use. And so, you don't actually have to convert it to a radian angle, okay? But make sure, because this is not something we can easily calculate by hand. So uh, most likely we are going to use like a calculator or the computer, right, to calculate cosine value of that. So you can leave, you can keep on using the degree angle measurement. But make sure that if you use your calculator, the degree option is set in the degree angle measurement, not radians. Okay, right. But in my case, I'm gonna use radian measurement. All right, so we are going to apply, okay, we are going to apply the law of cosine here because we know the angle theta is given. So, using law of cosine, so we have a squared equals to b squared, which is 13 squared plus c squared minus 2bc, okay? 2 times 13 times c cosine theta, which is 11 over 18 pi. So we have a squared equals, like I said, b squared, b equals 13 kilometers, okay, the altitude of the airplane when it passes the radar station on the ground, right? So 13 squared plus c squared minus 2 times b, 13 times c, bc, times cosine of 11 over 18 pi. Yeah, that looks like for confusing. 11 pi. Okay, so actually I forgot pi there, right? Earlier. Sorry. Pi radian. Okay, so we are trying to find what is that. The question is at what rate is the distance from the airplane to the radar station increasing, right? 3 minutes later. Okay, so we are trying to find the dAdt because A is the distance between the radar station and the airplane. Okay, airplane at in 3 minutes. Okay, right. So we are trying to find the dAdt. So obviously, we are going to differentiate this. Okay, so by differentiating with respect to t, we have dA 2 times a multiplied by dA by dt. 13 squared cancels. Okay, that's constant. I have 2c dc by dt minus 2 times 13. I know it's 26, but I'm going to leave it like that. And then dc by dt cosine 11 over 18 pi, which is going to be a numerical value, when calculated using a calculator or a computer. So divide this result, all right? Divide this result by 2a. We have dA over dt equals to c over a dc dt and minus 13 over a dc dt. Now you see why I left the like 2 times 13 instead of 26. Okay, and cosine 11 over 18 pi. Okay, so once we know c and a and then dc by dt, then we can calculate dAdt. Okay, so what's known here? Um, a plane flying with a constant speed of 29 kilometers per minute. Okay, so we know the dc dt, how fast the plane is at the moment, the flying at a constant speed. Okay, 29 kilometers per minute. And c is the how far airplane flew after passing the radar station. Okay, so how do we calculate that? Easy. because the plane's speed is constant at the moment. So that's 29 kilometers per minute. So c is going to be in 3 minutes, right? So that's going to be 3 times 29 kilometers. That's how far the plane flew away, after passing, the radar station. Okay, which is going to be 87 kilometers. So we know C also. Okay, so let's write those down, the quantities we know. Okay, so C equals, let me write down dc by dt first. dc by dt, that's 29 kilometers per uh, minute, and c is 29 times 3, so that's going to be 87, right? 87 kilometers in 3 minutes, right? It flew 87 kilometers. Okay, so what else do we have to know? Then all we have to figure out is A, right? So how do we find A? We have this equation here, okay? So let me use this equation. I think I did use equation number 1. So equation number 2. So using the equation number 2, we can also find A. Okay, so A is going to be square root of 13 squared